Good afternoon, grade 10s. It's me again, Hector Nkosi. I'm sorry, last week, guys, we had a misunderstanding. Actually, I'm supposed to finish with you this week, not next week. So, yeah, I'm sorry about that. I know I've already sent my goodbyes to you guys, but it was just a minor misunderstanding. So, yeah, as usual, I'll be taking you for mathematics. Feel free to ask if you've got any questions. You can always send your queries in the chat box. I'm more than welcome to answer your queries. Or if you've got any maths related questions, you can always send them at ngosihector28@gmail.com. So today we're still looking at functions, but part 2 of the functions. Why are we doing functions for 2 weeks? Because this is the chapter that is being dealt in term 2, basically. So I need to teach it as if like I'm teaching it in class. So as per the annual teaching plan, this needs to be taught for a full 2 weeks, But the chapters that you've dealt with them in term 1, that those are the only chapters that I can only teach them for a week. But the ones that you haven't seen and stuff like that, I need to teach them for 2 weeks. So no wonder again, we're still looking at functions because I know some of you are still struggling with functions. Some of you are still having problems when it comes to functions. I mean, we only did few questions last week because we were still trying to, I was still trying to get you guys to the mode of doing the functions. All right, guys, I can see comments on the chat box. Let me just read at the chat box. Hi, Tracy. Hello, Tino. Yeah, guys, as I said earlier on to you, there was a misunderstanding. I'm actually ending this week, not next week. So I'm still with you guys this week. So yeah, I hope you are well. Okay, cool. All right. Okay. It's fine to have you back, guys. Tracy, he's saying we really don't mind. I really don't mind too, guys. It's very nice to have you guys. You know, okay, cool. All right, guys, I just want to recap with functions. So here I've got learning outcomes, and I would really want you to look at these learning outcomes, boys and girls. So we have dealt with a straight line graph, and the straight line graph, the equation of a straight line graph looks like y is equals to mx plus c. We have also dealt with a parabola graph, and a parabola graph, its equation looks like y is equals to ax squared plus bx plus c. We then looked at the hyperbola graph, and its equation looked like y is equals to a over x plus q. We then looked at the exponential graph, and its equation looks like y is equals to ax squared plus q. So by now, guys, you need to be familiar with these equations. You need to be familiar with these four graphs. The straight line graph, you've dealt with it in grade 9. So by now, you should be fine with the straight line graph. However, the parabola graph, the hyperbola graph, and the exponential graph, these are the new graphs in grade 10. But the whole of term 1, when you were doing algebra, we have dealt with how to solve for x in a parabola, how to solve for x in a fraction, that's a hyperbola graph, how to solve for x in an exponential graph, right? So you know how to solve for x in these, but you never knew how to what you call to draw their graphs. And the last three graphs, guys, we call them non-linear graphs. The first one, of which is a straight line graph, we call it a linear graph, right? This is the linear graph. The last three is the non-linear graph, boys and girls. Okay, I hope you are familiar with these formulas. Please make sure that you memorize them, you know them, so that come exam, you know that what is what. Basically, these things, guys, are the things that you have dealt with from when from term 1, where you solve for x in a straight line, you solve for x when you are given a squared, you solve for x when you are given a fraction, you you solve for x when you are given an exponent, basically. So these are the things that you've dealt with so far. You know them. It's just that now with bringing them in the picture. Why do I say in the picture in a form of a graph, right? All right, boys and girls. I can see there's a comment. Okay, cool. Oh, yes, Poppy. So I'm still living, guys. So I'm finishing with you guys on Friday, right? So yeah, I'm sorry. I'm sorry, guys. I thought I was finishing next week, last week. So I'm finishing this week actually. So I'm still going to be with you at least, guys, for more 4 days or 3 days this week. So don't worry. But feel free to always ask me questions if you've got any problems, guys. Right. All right. Then now I need to take you to our today's lessons. Let me just check who's new today. Okay, people are here as usual. I can see there's a new person, Aseri. Um, welcome to our class. Elizabeth, Israel, it's my first time seeing you. Others are always here. Homotso, welcome. Okay, S, welcome. Okay, others are always here, guys. I'm just welcoming the ones that I think it's their first time here in our class. Guys, please feel free to ask questions in the chat box. That's how we operate. If you've got any queries, you are more than welcome to also email me. Right. Okay, cool. Let's start with our today's lesson. Okay. Right. I need to share the screen. Okay. So, boys and girls, today we'll be looking at this question. This question was taken from November 2018, right? So this was question 5, basically. This is the combination of what? This is the combination, guys, of a hyperbola graph and a parabola graph. So this is a parabola graph of which is given by f of x, and you are given the hyperbola graph of which is given by g of x. So the instructions are saying here, sketched below are the graphs of f of x, of which is ax squared plus q. It's this one. F of x is the parabola, and g of x, of which is what? Is the hyperbola. Uh, yeah, this basically g of x. It's not a hyperbola, but it's an exponential graph. Yes, so it's the combination of a parabola and the exponential graph. So g of x says half to the power x minus 4, meaning now -4, that's where the y-axis cuts. That's the value of d, right? Okay, it says a and b are the x-intercepts of f, so a and b are the x-intercept of f, I mean to say. The graph intersected a, so it intersected a and point E. Where is point E? Point E, I can't see. Okay, here's point E. So that's point E. Okay, so these are the intersects. So we've got point E and point A, right? Okay. Okay, and point E lies on the f-axis. Okay. C is the turning point. We call this curve, guys, a turning point, because that's where the parabola turns, guys. It's a turning point, right? That's point C, right? Turning point of f, and D is the y-intercept of G. So D is the y-intercept of G, right? So basically, guys, one thing I've never explained to you. So a parabola graph, the graph like this, normally you've seen it like this. So in this case, it has the set face. We call this a hyperbola that has a set face because it's facing downwards. So one thing I want to tell you guys, if it has the set face, the a, this ax squared is always negative if it has the set face. But if it has the happy face, it's like this a, it's always going to be positive. So They haven't told us the value of A, but they would say we need to calculate it. But just know that because it by looking, it has the set face, meaning now that your A should be negative, right? That's your starting point, right? That's one thing I've never discussed with you. Now, 5.1 and 5.11, it says write down the coordinates of D. So basically here we need to write the coordinates of D. D is what? Is the y-intercept of G. Here's G. G of x is equals to half to the power x negative 4. So what are the coordinates of D? Who can tell me? The coordinates of D, what are the coordinates of D? Who can tell me, boys and girls? Okay, I can see a chat. On Tatile got 0 is to negative 3. Okay. Okay, on Tatile, do you mind to tell us how you got negative 3? Aaron got negative 4. 0 is to negative 4. Okay. Do you guys mind? Okay. I know who's right, who's incorrect, right? So basically, the answer is 0 is to negative 4. Aaron, can I unmute you so that you can tell us why you got negative 4? Because the answer is indeed negative 4. 0 is to negative 4. Okay. Hello, Aaron. Hello, Aaron. Okay, it seems like I can't unmute you, Aaron. I don't know what's happening.
Hello, sir.
Hello, Aaron. Just wait. Hello, Aaron.
What? Hello,
Hello.
sir.
How are you, my boy?
I'm fine, sir.
Great, great. Do you mind to explain to us how you got 0 is to negative 4?
So, sir, here you
Yeah.
say that what's this on G of X?
Yes,
You
very
said
good.
what's this? The Y. It's same as
Yes.
saying Y. So the Y is equals to -4. Cause yes.
Okay, yes, that's perfect. So, yes, that's perfect. Aaron, thank you so much, my boy. Hey?
Yes.
Okay. Okay. So, you can do it in two ways, guys. You can do it by inspection, right? Let me tell you when you do it by inspection. That's the easiest way. So by inspection, you can say, oh, okay. So now g of x can be written as y is equals to 1 over 2 to the power of x minus 4. So basically, you know that this negative 4, it's where your y-intercept of g are, right? So basically, you can always say d is 0 is to negative 4. Why 0 is to negative 4? Because d is lying on the x-axis. Remember, I said to you, if the point is lying on the y-axis, x is always 0. If the point is always lying on the x-axis, y is always 0. But if the point is not lying within the Cartesian plane, like your point E is lying not in these lines, is just lying outside the lines, it's always going to be is to something, you know. But now, if something is lying in this cross, guys, if it's a vertical point that is lying somewhere here, which means the coordinates, it's always 0 is to something because it's lying on the y-axis, right? But if it's lying on the horizontal line, of which is your x-axis, which means x is always x is to something is to 0, basically, right? So no wonder we got 0 is to negative 4, because we know that d is lying on the y-axis, and here on the x-axis your x is equals to 0. I mean, on your y-axis, your x is equals to 0. Here on the x-axis, your y is equals to 0. Here on the y-axis, your x is equals to 0. I hope I'm making sense, boys and girls, right? Secondly, what you can do here, Since you know that x is 0 in this line, you can substitute 0 there by saying y is equals to half to the power 0. Where there is x, you can put 0, right? And you know that something to the power 0, it will be 1, basically, right? So it will be 1. So it's going to be 1 minus 4. So 1 minus 4, it's negative 3. Ontatile might be right. So it might be negative 3. Let's check. Yes, actually Ontatile, she's right. I mean, he's right, Ontatile. The answer is 0 is to negative 3, boys and girls, right? I'm sorry, Ontatile. Yes, the answer is 0 is to negative 3, basically. Well done, Ontatile. It's not negative 4, but is negative 3, basically, guys. You see, it's very important for us, guys, to do questions step by step. Because now, if I did not say half to the power of 0, these are the laws of exponents, guys. Remember, something to the power of 0, it's always 1. A to the power of 0 is 1. Any number or any variable to the power of 0, it's always 1. Then 1 minus 4, it's minus 3. Therefore, y is equals to negative 3. No wonder the coordinates of D, it will be 0 is to negative 3, not 0 is to negative 4. However, this is y is equals to 4, right? The asymptotes. These are the asymptotes. Remember what are the asymptotes? The asymptote is the line, is the maximum line, like your range, where g of x will not go beyond this line, right? Will not go beyond this line. We'll call this a line of an asymptote. The line with dot dot is the one that will be y is equals to 4. Yes, good, Tracy. It cannot cross that line, basically. This line with dot dot, we call it a line of asymptote, guys, right? So you should know this by now, right? Perfect. So is the coordinates of D is 0 is to negative 3. Okay. Then now it says 5.1.2. What is the range of G? Who can tell me what did I say the range is? The range of G, this is the G of X. What is its range? What is its maximum? So the graph of G, it cannot reach what? It cannot reach negative 4, guys, because here it's negative 4, right? We said here it was negative 3, here it's negative 4. And how did you get your negative 4? Through the graph of g of x, because this is your q. Q, it's when the graph goes down or go up. So if it's minus 4, meaning the graph is going down. If it was plus 4, which means the graph was going up. Does it make sense, boys and girls? So your q's, guys, let me go back to my equations and explain my q's. So your Q's, guys, these Q's, remember these Q's, guys, the Q here tells you that the graph goes how many times up, how many times down. If it's minus Q, which means the graph is going down. If it's plus Q, the graph is going up. Same as the exponential graph. If it's plus Q, which means the graph is going down, I mean, it's going up. If it's minus Q, the graph is going down. Same applies with the parabola. This plus C indicates basically your y-intercepts. Even your plus C for the straight line indicates your what you call your y-intercept. So it's just that the straight line in a parabola uses C for going up and going downwards. Your hyperbola and exponential uses Q for the indication of going up and going down, right? Okay, cool. Right, I need to go back to the question. Right. Okay, boys and girls. Now the range, it will be y is must be greater than -4, right? So it must be greater than -4, meaning why I'm saying greater than -4, because we know that -3 is always bigger than -4. -2, it's always bigger than -4. Remember your integers, guys. So if I were to ask you, what is the biggest number between -4 and -2? -2 is bigger, right? I'm sure you still remember your integers, right? So your 0 is bigger than your -4, right? So because here everything is decreasing, right? So y is greater than -4. So that's your range. Remember, the range is the maximum that the y-axis can reach. So no wonder we say range is when y is greater than -4. And your range is the same as your line of your asymptote. Remember, I said you can always call it the line of asymptote. You'll see in grade 11, they'll be speaking about the line of asymptote. They'll be asking you, what is the line of asymptote? They are referring to this line with dotted lines. Yeah. Then now, 5.2 says calculate the coordinates of A. Let's look at A. So this is point A. So we need to calculate the coordinates of A. Easy. Who can tell me this one? A is the intersection of F and G. So who can tell me the coordinates of A? The coordinates of A, guys. You see the importance for us to do functions even this week, because I can tell that majority of you are still struggling when it comes to functions, are still not sure about your stuff. Who can tell me the coordinates of A? Coordinates of A, guys, going once. You don't have to give me the answer straight, but you can tell me, okay, say this is what we need to do and stuff like that. Who can tell me? Going twice, going thrice. Okay. Seems like everyone, it's a Monday. People are still recouping from the weekend. It's fine. I'll explain to you guys. Okay. Okay. Tino got -6s to 0. Tino, do you mind to tell us how you got -6s to 0? Tino, can I unmute you? Okay. Tino is quiet. Let me, okay. You're saying yes. Okay, cool. Hi, Tino. Hello, Tino. Tino, I have unmuted you. Hello. Hi, Tino. Okay, I don't know what's happening with Tino. You said yes, I can unmute you, but yet you're not talking. Hello, Tino. Okay, guys, it seems like there's a technical problem when it comes to Tino, guys. Okay, let me unmute you again because there is no voice projection. Okay, cool. So basically, Tino got -6s to 0, right? Now, because, okay, I see a chat. Okay, Tracy says, I agree with her. Okay, Tino said she got it by inspection. Okay, well done. But I tried to unmute you. Okay, Tracy also said he got it by inspection too. Oh, Tino is a boy. Sorry, my boy. Oh, okay. Okay, sorry about that. So Tino said he got it by inspection. Okay, but do you mind to explain to us? Because guys, I'm sure you've got other methods that you can share with the class. That no wonder I like to unmute people so that they can talk, everyone can hear how they got their answers, because I'm learning from you as much as you're learning from me, guys. That's why this class is very versatile, the way we do things. We try to hear what other views, what other views from other people, because learning is a process, guys, and I appreciate you so much, guys, with your participation. Let me try to unmute you again, Tino, so that you can tell us. Hello, Tino. Tino, are you there? I have unmuted you. Can you hear me, Tino? Okay, there's a problem with Tino. I'm going to unmute him again. All right, guys, let me just explain how I would do it right? So now, how I would get the coordinates of A, right? So we know that A is where it intersect what? It intersect graph of G and graph of F. So I know that, okay, I would use, because equation of f of x I'm not given, I'm given as a plus x squared plus q. I don't know what the value of a is. I don't know what the value of q is. So what I will do, I would use g of x, since g of x is also affected in point A. So I'll be like, okay, where is point A? Point A is on the x-axis, basically, right? So which means on the x-axis, y must be 0, basically, as we did with the D. Remember, for D, when we wanted the point D, we made point D what? We made point D, we made x 0 because point D was lying on the y-axis. But now point A is lying on the x-axis, which means we must make what? Y 0. So that's what I'm going to do so that I can get what? I can get the value of A. So now, remember, g of x, guys, is the same as y is equals to half to the power of x minus 4. So where there is y, I'll put 0, right? So there will be 0 here. Then when I transpose 4 to the other side, it's going to be 4 is equals to half to the power of x, right? Then half can be written as 2 to the power of -1, right? Half can be written as 2 to the power of -1. So now 4 can be written as 2 to the power of 2. Then when I drop the bases, I'll be left with what? I'll be left with, you'll be left with 2 and 2. So basically your x can be equals to negative something. Let me just show you with the solution. So basically what we're going to do is this. So your x will be equals to -2, not -6. But thanks for trying, guys. So basically we said now let's make y 0, right? Because now we know that point A is lying on the x-axis, so we can make y 0, right? Therefore, after we've made y 0, we're going to say, okay, let's take 4 to the other side. When you take 4 to the other side, this can be written as 2 to the power of negative, to the power of -1, of which is 2 to the power of negative x is equals to 2. Therefore, we know that 2 to the power of negative x is equals to 2 to the power of 2, because we know that 4 can be written as 2 to the power of 2. Therefore, when you drop the bases, guys, remember when you solve for x using the what you call the exponent equations, you drop the bases 2 and 2. Therefore, x is equals to -2, because you're going to divide by -1 both sides, -1 both sides. Therefore, here it will be -2. So x is equals to -2. Therefore, the point of A is -2 is to 0, basically, right? So that's how we got -2 is to 0, boys and girls, right? I hope it makes sense. I'm just going to project it one last time so that you can see it, guys, because now we are doing this thing, and I want you guys to be more comfortable with it. You see, functions are very important. Unfortunately, I cannot teach functions for a week, because as I said to you guys, functions, they form part of your term 2 stuff. So I cannot teach them for a week. The least I can teach them is for like 2 weeks and a half. Already we are done with 1 week. This is our second week on functions. So by now, everything should start to make sense, even though it doesn't make sense that much, but it should start to make sense. Then all the term twos work, we're going to cover them for 2 weeks, guys. But things that you have covered in term one, because you're already familiar with them and stuff like that, it's good to do them for a week only, for 1 week, right? But for things that you have dealt with them in term two, because you haven't seen them, it's your first time doing them, it's good to do them in term two. I mean, in 2 weeks, basically. All right. Let's look at the next question. So the next question now, it's saying to you, calculate the values of A and Q. So basically, they want the values of A and Q. So if you look here, it says the sketch below are the graphs of f of x is equals to ax squared plus q. So basically, you're looking for the value of A and value of Q. Basically, we have to calculate these 2 points, basically, right? So yes, we can calculate these 2 points. Remember now, we do have 2 points that are lying where in your f of x. We've got point A, of which we got -2 is to 0. We also have another point of which is point E, right? That is 1 is to 3. So when you've got 2 points, you can actually calculate what? You can calculate um your value of A and Q, right? So in grade 11, you'll deal with this thing that calls we call it a difference of two squares, right? But now I want to show you this one. It's pretty much easy. I just want to show you this one. It's very easy also. So here, what we're going to do here, guys. So remember, in grade 11, you'll deal with this thing called a difference of two squares. But for now, it's fine, guys. Because you're still in grade 10, we don't want to be ahead. You must learn what you need to know in grade 10. Then when you get to grade 11, you'll learn what you need to know in grade 11. For now, use this formula of yours, guys, because now it says f of x is equals to ax squared plus q. So basically, you can take that point of E because it's lying in your f of x, 1 is to 3, right? So basically here, where there is y, you put 3, where there is x, you put 1. So you're going to have 3 is equals to a1, you put 1 in your x, all squared plus q. So basically, you're going to have this equation that you call it 3 is equals to a plus q. So this will be your equation 1 when you substitute point E. Then you can use another point, right? You do have another point, of which is point A, right? Point A was saying -2 is to 0, right? So now what you need to do is, okay, where there is y, you put 0. Where there is x, you put -2 with point A. So you substitute point E there. Here you substitute point A so that you can make 2 equations. Then can you see now you're going to have what? You're going to have simultaneous equation. Therefore, you need to solve for A and Q simultaneously. Can you see, guys? These are the things that you know, the things that you have dealt with. It's easy. So basically here you've substituted point A, therefore we know it's 0. Then this times that, it can be written as 4A plus Q. Therefore Q is equals to -4A, right? So you know the value of Q. So you can substitute your equation 2 into equation 1. So where there is Q, you can substitute by -4A. So here, where there is Q, you can put -4A. So no wonder you will get that A is equals to -1. Because when we substitute by -4A here, we're going to have what? A minus -4. What is A minus -4? It's minus 3A, right? So A minus -4A is the same as minus 3A. Therefore, you're going to have 3 is equals to -3A. When you divide by -3 both sides, you'll get A is equals to 1. So since you've got A is equals to -1, Here, you can substitute by -1 into A to get the value of Q. So -4 times -1 is 4, because a minus times a minus, it's a plus. Therefore, you do have the value of Q, you do have the value of A. The value of A is -1, the value of Q is 4, right? And yes, it makes sense, guys. Remember, I said to you at the start of this lesson, I said to you, when your parabola graph, of which is your f of x, if it has the set face, meaning that your a is negative, and yes, we find out that a is equals to -1. So no wonder now you've got a is equals to -1, because now your parabola graph, it has the set face. And if it had the happy face, which means your A was going to be positive and your graph was going to be shown like this. Set face, it's because it goes from here to there, boys and girls, right? Happy face, it's when it's facing like this. We say it's a happy face, right? And always your Q is always going to be positive, your value of C, if the graph has the set face. But if the graph has the happy face, your Q is going to lie somewhere here, your turning point, and it's going to be to have the negative sign, right? Okay, boys and girls, because this question is quite long, if I were to start to do the length of CD, I will just take much more time from you guys. So what I'm going to do, because we like 3 minutes left, so we're going to finish off these questions. So 5.3 and 5.4, we're finishing them tomorrow. Then yeah, we'll start another new question again. Maybe we'll be looking at November 2017 tomorrow. Oh, before November 2017, we can look at question 6 basically. So tomorrow we are finishing off 5.3, 5.4, and question 6. Then on Wednesday, we'll be looking at question what you call question November 2017. Then on Thursday and Friday, we can just look at what you call, we can look at more papers. I will tell you by then, closer to time, right? Thank you so much, guys. I'm happy to be with you again. You guys are so amazing. Thank you so much for listening. Yeah, I'll see you again, same time, guys. Don't forget, the time has changed. It's no longer 3 o'clock, but it's 2 o'clock, right? Just tell your other friends that they should tune in tomorrow. We're starting at 2. It's no longer 3 p.m. Okay, guys. Okay, from my side, thank you so much, guys. Have a lovely evening. Bye.